Hey everybody, welcome back to Young Engineers of Today. Hope you had a good couple of days. I apologize if I seem a little bit out of it today, or if I just stop talking mid-sentence. The weather's kind of messing with my sinuses, so there's a little bit of nose running and sneezing happening right now, but nothing that, will keep me from being able to do this kind of stuff. At any rate, um, on Monday we went over inputs. So we talked about analog inputs and digital inputs. Analog inputs in this case are inputs that you can read anywhere from 0 to full power, anything in between included. So it could be 0 volts, could be 5 volts, could be 3.5 volts, could be 2.4 volts, so on and so forth. Digital reads only read either an on or an off. So either you are registering off or on, no values in between. Usually the way a digital input works is a threshold voltage. So, if you get above I don't know, 4 volts, it's counted as on. Below 4 volts is counted as off, even if ideally you're taking in 5 volts, because you want to allow for a little bit of play with circuits and stuff like that. But the end result is the value you get back is either going to be an on or an off. You're not going to actually be getting the full information as far as that's concerned, like the amount of voltage that it's actually reading. It's just either going to be above or below that threshold. We played around with that by creating a circuit with a button. Let me go ahead and see. I think this is it. We'll know for sure once it actually loads. Yes, this one. So if I were to go back into this, you guys don't have to go back into this too. I just want to show it as an example. Once it eventually loads, there we go. And start the simulation, we could press the button and have the LED turn on. We also messed around a little bit with the serial monitor. So if I open up the code editor and the serial monitor will be reading nothing because we took that out. That's right. Okay, well, we also talked about the serial monitor and how we can look at like sort of inside the brain of the Arduino and see what's happening by writing our own serial print debug messages. But regardless, we can click the button, we can press the button, have the LED turn on, let go of the button, have the LED turn off. We can press the button in rapid succession and have the LED get brighter or dimmer depending upon how quickly we press the button. Which is kind of neat too. So if we press the button pretty slowly, we keep the LED fairly dim. If we press the button very quickly, assuming it's not too quick for this thing to register, the LED gets pretty bright. So there you go. That's neither here nor there. That's an aside point that we can probably get into later. I just wanted to show off that little bit. But that was our entire purpose on Monday, was to talk about how we can combine inputs and outputs. Now, we can do a whole bunch of stuff with that. We can actually mess around a little bit with analog inputs, so that you guys can actually see what's going on with an analog input versus a digital input. When we use the serial monitor for the digital input, it would output a 0 unless the button was currently being pressed. So we could hold down the button and it would print out a 1. What we're going to do is we're going to mess around with an analog input in the form of a potentiometer. Now, a potentiometer is just simply a type of resistor. That's all it is. It's a type of resistor that resists more when you turn it in a certain direction and resists less when you turn it in the other direction. How many of you have a stereo system or a car that has a stereo in it? Okay. Do you have a volume knob, or do you have buttons for the volume? volume knob. Guess what that volume knob is? It's a potentiometer. That's all it is. A volume knob on a sound system is simply a potentiometer. So once you mess around with this, you might have a better idea of how the volume knob works on your stereo. So a variable resistor. What exactly do I mean by that? Well, we've got our resistors, our 330 ohm and our, 10,000 ohm and 1,000 ohm and all these different types of resistors, right? Well, those are set fixed values. We put in a 330 ohm resistor into our circuit. It's going to resist 330 ohms no matter what. I mean, obviously, due to manufacturing tolerances and stuff like that, maybe it'll only resist 315 ohms, or maybe it'll resist a little bit better and it'll be 345 ohms, something like that. But regardless of what it actually resists, that value doesn't change. It's not like a 345 ohm resistor will suddenly resist 360 ohms or 330 ohms or whatever. It's going to resist 345 ohms worth of, basically it's going to be that resistive always and forever until it starts to fail, in which case it'll start resisting less. But variable resistors, their power lies in the ability to change their resistance while the circuit is running. We actually talked a little bit about a variable resistor last time around in LDR. Now an LDR changes its resistance based on the amount of light that is shining on it. If you put an LDR in an entirely dark room, it will be a very strong resistor. If you put it out in bright daylight or shine a flashlight directly onto it, it is a very weak resistor. Now, since it is analog, it actually, not only will it be able to do its full resistance ability or be a very weak resistor, it will resist all of those values in between depending upon the ambient light. So if you turn up the light slowly, it will slowly over time become a weaker and weaker resistor. Turn down the light slowly, it will slowly over time become a stronger and stronger resistor. So that is the power behind it. We have the ability to change the resistance on a circuit and thus the flow of electricity, basically based on the amount of light that is shining on your circuit, which can be cool for a few different things. You can have lights that light up when it gets dark outside and turn off when it becomes daylight again. You can have certain types of motion detectors that detect very close motion, like if somebody passes in front of something, they can go off. You can have, who knows? Basically anything that you need that's based off of light, you can build using an LDR. There was a robot we were building a while ago, and one of the things it had to do was it had to grab red pegs while leaving green pegs alone. And we actually used an LDR for that. The hilarious thing was, since an LDR reads an entire spectrum of light, and we needed red, the way we fixed that was we put some red cellophane over the LDR. Part of what makes something red, like red cellophane, is it only lets red light through. So if you shine, okay, let me explain this a little bit better. Let's say we have a piece of red cellophane. It looks red because red light is able to get through, whereas other colors of light bounce off. So thus, to our eyes, it looks green. The opposite is for red objects, solid objects, like paints and things like that. The reason why a red paint looks red is because red light bounces off of it and other light gets absorbed into it, in essence. I mean, that's basically what's happening. So you put an LDR here behind this red cellophane, and then you have a flashlight that shines. Well, it shines through the red cellophane, only red light comes out. It bounces off the red object and goes back into the LDR. If this were a green object, the red light would simply be absorbed on the object. So we actually turned an LED, or excuse me, an LDR into a color detector using a piece of colored plastic, which I think is kind of funny. But, you can do stuff like that. You can actually detect for certain colors using colored plastic, if you were so inclined. Excuse me. I apologize. I don't know if you can hear me like sniffling and stuff like that. I apologize if you can. But I got way off base here. We were talking about potentiometers. Potentiometers are a type of variable resistor. I just kind of like LDRs. I think they're pretty cool, so I got stuck on a little bit of a tangent there. But potentiometers are knobs. Literally, like that's not an insult. They're knobs. They're knobs that you can turn and they change the resistance. Basically, the electricity comes in on one terminal and goes out on one of the other two. So let's say electricity is coming in here through terminal A. Now the electricity has a couple of different options. It can travel all the way around this circuit and out the other end through terminal B. Or it can travel part of the way around up on this little, they call it a wiper, but up on this little wiper here and then travel out W, the wiper circuit. Which one it goes through depends upon where this wiper is turned. If it's turned all the way to the end, well, the wiper has some resistance of its own, so it has to travel all the way around this resistive area, and it doesn't want to, travel up the wiper because there's more resistance there. It might as well just go out the end of the circuit, in which case you have a pretty high resistance on this potentiometer. In addition, you can also use a potentiometer to gauge how much electricity is going to be going through. So very little electricity is going to be going down W, thus the potentiometer is a very, very resistive element. Now let's say you turned it all the way to the left, all the way counterclockwise, so it's over here. So now the wiper is over here instead. Well, the electricity doesn't have to travel very far. It hits the wiper, and there is much less resistance down this wiper than there is all the way around the circuit, so it's going to travel up the wiper and go out the wiper circuit. Thus, on this circuit right here, the potentiometer is said to have a very low resistance. And that changes as you turn it. As you turn it, more of the electricity is going to travel down B and less is going to travel down W, and thus you're going to increase the resistance on W by turning the potentiometer. Hopefully that made sense. Basically, the potentiometer affects voltage on the other two circuits. The important thing for you to know is you turn the knob and you either increase or decrease resistance. So you can use the potentiometer to control the brightness of an LED, to control a servo, to adjust the volume of a music player. You can do all of these things. A potentiometer is good for all of these things. Potentiometers are dimmers. So if you have like one of those light switches that's a knob in like your dining room or something like that, or maybe it's in your, maybe it's in the living room or something, who knows. But as you turn it, the light either gets brighter or dimmer. That's a potentiometer. If you have, let's see here. Nobody really has screen dimmers on like handheld, like physical screen dimmers on handheld devices anymore. But that would be the same basic thing. We already went over a volume knob. Servos also change their position based on how much electricity is going into them, so you can use a potentiometer to turn it. So that would be kind of like a there aren't many examples of that. Certainly none that I can think of course. Not at this moment. But anyway, you can do that too. That's that's what I'm more going at. You can do a few things with the potentiometer. They have their place and their use. So now what we're going to do is we're going to build a circuit that takes advantage of a potentiometer. Woo! Yeah, excellent. Because circuits does have support built in for potentiometers. Potentiometers are like manipulatable things in circuits, and they will simulate real potentiometers. So that's what we're going to do. We're going to mess around with one of those. So here's the circuit we're going to build. And I'll bring up a more helpful diagram in a moment. There. Now this one may not seem that helpful, but it'll make more sense in a minute. Let's go ahead and bring up a new circuit in 123D circuits. Oh wow, it was simulating that entire time. Okay. Apparently, according to circuits.io, one of those circuits, the last time I messed around with it was tomorrow. So I don't know what time zone they're in. Maybe they're using GMT, because that would technically make it tomorrow. If you're ever curious, I think we are 5 hours behind GMT. Yeah. Which is Greenwich Mean Time, which is like the international standard for time that everything else is based off of. Because apparently Greenwich is super important. Spelled Greenwich. Yeah, let me double check that. We are 4 hours behind Greenwich Mean Time. I think that changes when daylight savings time ends. So, yeah, we become 5 hours behind. Actually, I believe the first week of November. But there you go. Is the mean solar time at the Royal Observatory in Greenwich, London. GMT was formerly used as the International Civil Time. There's another little aside for you. Now let's go ahead and start building the circuit before I get sidetracked yet again. Here we are with our breadboard. I'm going to rotate it 90 degrees like I always do, and we are going to include a couple more components for our electronic use. I'm going to bring out our basic resistor again and our basic LED again, because basically a lot of our circuits are going to involve making a light blink, which doesn't sound that exciting, but you know, we could be doing a lot worse. But there you go. So we got to bring out our LED and our resistor. We also have to bring out our Arduino, obviously, because we need an Arduino in order to use an Arduino. Just saying. And then we are going to bring out our potentiometer. We're going to use our regular plain old potentiometer. You can just type in pot, which is actually shorthand for a potentiometer. If somebody says, hey, you know, I'm trying to work on the circuit here, can you hand me one of those pots over there? They're talking about a potentiometer, not actually a piece of ceramic. Just so you know in the future. But this is our potentiometer. This is what we're going to use for our circuit here. So now we've got our resistor, we've got our LED, and we've got our potentiometer. We're going to change our resistor to 330 ohms, just like we always do. Boom, 330 ohms. I really hope I did that correctly because I couldn't actually see what it was. Yeah, 330 ohms. Okay, excellent. The GoToWebinar screen was in the way. And let's go ahead and cozy up our Arduino to our breadboard like we always do. And let's start building our circuit. So now what we want to do is we want the Arduino to read input from the potentiometer and then send output to the LED. We could actually set up this whole thing so that the Arduino is completely superfluous. But we can do some more interesting things with the Arduino as well that we cannot normally do with just a physical circuit. So we're going to take full advantage of those. So here, what I'm going to do is I'm going to take this potentiometer. I'm going to stick it over here on the right-hand side, like so. Left-hand side. Well, left-hand side of the breadboard, which is on the right-hand side. I could probably make this more confusing, but it would take some effort on my part. Anyway, put it there on that part of the breadboard. Ugh, I can't talk. Then we're going to set up our basic LED resistor combo. Make sure you've got the resistor going to the negative rail and hooked up to the cathode of the resistor. So now we've got basically two separate sets of components for two separate circuits. And then we're going to hook this up to the Arduino. So now it should be said, we're going to have this LED hooked up to pin 13 on the Arduino, just because of convention, because we do that a lot. I'm going to set it to be yellow just to make it a little bit easier to see. There we go. So pin 13 is plugged into the anode on the LED, the bendy leg, and then the non-bendy leg has the electricity going out. And then we're going to hook some stuff up to the potentiometer. But here's what we're going to do. So if a lot of our stuff is going to be based on here, let me just do this. Let's go back to our diagram of the potentiometer. Can you hazard a guess as to which leg of the potentiometer is going to be plugged into the Arduino? Based on this little diagram here. A is going to be taking in power. So it's a good guess, but that's going to be actually hooked up to our power. Think about what gets affected by turning the knob. Okay, so yeah, you're technically right. Sorry, I meant input. I mean, where's it going to send the input to? Yes. Yeah, sorry. Okay. Yeah, you're technically right. You're totally, in fact, all three of them are going to be hooked up to the Arduino because the Arduino is acting as power and ground. So yes, you're technically correct, which according to Futurama is the best kind of correct. But what I was looking for was W. W is going to be our, what's going to be hooked up to our analog input on the Arduino. So I hooked up the third terminal to the negative rail, flying in the face of everything I was just talking about because it was the first thing that occurred to me. But let's go ahead and do that. So I'm going to hook up this, the wiper, to A0. And I'm just going to kind of bring it over here, and I'm going to make a bendy here, and I'm going to make a bendy here, and then I'm going to hook it up. Bam! And let's go ahead and straighten all this business out. So now we can see we got this nice snaky line over to A0. Doesn't look exactly pretty, but it'll do the trick for now. And then we're going to have 5 volt hooked up to the first pin on the pot. Oh no, we're going to make it red. Red. There, so now we know it's hot. And then we're going to hook up our ground line, our ground rail, to the ground pin. There. So this is what our circuit looks like. It's a little weird and confusing, but, you know, taking a look at it and disassembling it step by step, it's actually not too bad. We've got a couple of things hooked up to our ground, which is why we created a common ground rail. And we've got one thing hooked up to our 5 volt, which is why it's hooked directly up to the 5 volt. That's our potentiometer. And we got one thing hooked up to A0, which is the middle wire, the wiper terminal on our potentiometer. We've got our LED hooked up to pin 13, and then the other end of it is hooked up to the ground through the resistor, just like we've always done with our LEDs. So there we go. That is our circuit. Not too bad, right? Like that was, it looks a little weird just because there's no real convenient place to put all of these wires, but the actual building of the circuit itself is not too bad. So let's see what the programming side of this is going to look like. It's probably going to look pretty familiar, but there's going to be some new stuff as well. So let me go ahead and bring up Notepad so I can make this larger. Inti. We're going to go ahead and set up our pins as variables again, just to get into the practice of using variables. And you might have some questions about this third variable here. We'll get to that in a second. But for now, we've got sensor pin, LED pin, and sensor value. And all three of these are integer variables. You could probably guess at what the first two do. So far, so good, right? Now, of course, we need our void setup and our void loop. And let's go ahead and do our curly brackets. Whoops. So now we got the skeleton of our program set up. Now what do we have to do next? What should we be doing in setup? Massive sneeze. Think back to what we've done in our previous programs with the LED pins. Oh, you haven't? Okay, let me bring it back up. There you go. Sorry about that. I guess raise your hands once you're done. Oops. What is the black cord in ground? That's a jumper cable. I just clicked and created a connection, but I colored it black and put some bends in it so it was easier to see. Where is it connected to? It's connected to this negative rail over here on the right hand side. See, it goes all the way down here, bam, and then this negative rail is where the resistor and then the third terminal on the potentiometer is plugged into. I apologize, I didn't realize that most of you weren't actually done with the circuit yet. Jumped the gun a little bit there. All right, wait a couple more hands. Down. As in you've got it down. Whoa. My circuit won't work. Why do you say that? What about it? Ow! Duh, you're totally right. Oh my gosh. uh, let this be a lesson to everybody. I am not at 100% right now. What is wrong with my circuit? Mateo already knows. Oh my gosh, how long have I been staring at that? I'll give you a hint. How are all the rails connected on a breadboard? We'll get there, no worries. I have nothing connected to any of the terminals on the breadboard, or excuse me, the potentiometer. So, everybody, let's go ahead and rotate this potentiometer 90 degrees. Hey. And you can change the where something is connected by clicking on it, so you get the little dots up again, and then you can just move the dot to another terminal. In this case, I want to connect each one of these to a different spot on the potentiometer. There we go. Hey, I are good and smart. There, now we're actually going to be reading values in on analog that are useful. It's always good to troubleshoot your circuits. Okay, so now our circuit is right. Raise your hand if you've made that change. All right, just about everybody. Thankfully, that was a much smaller change. Dear Lord. Okay. I'll put the code up right next to it so you guys can look at both at the same time in case you need to. So going back to the code real quick, what exactly do we need to do here in setup? Well, we have to initialize our pins, right? So let's go ahead and do that. Pin mode, sensor pin, input, pin mode, LED pin, output, right? Because we want to be sending values out on the LED, and we want to be reading values in from the sensor. Sensor pin is labeled as 0, and as you might notice here on our circuit, the potentiometer is plugged into A0, not just A0, but it's actually labeled the letter A and the numeral 0. Let me move it out of the way. There you go. See, like that. So it's actually A0, A being short for analog. So we got A0. We just call it 0 here. It's shorthand for A0. You can't do that for most of them just because, well, no, actually you can, because if you say analog read. Anyway. And then LED pin, of course, is pin 13 for obvious reasons, because it's plugged into pin 13. Sensor value is still at 0, and we haven't done anything with sensor value yet. You'll see what we'll do with sensor value in a minute. So now we got our pins set up. Now we actually need to start doing stuff with our pins. And we're going to do something a little bit interesting. In fact, before we do that, we're actually going to set up a serial output, if you remember that from Monday, just so we can actually watch values on the serial monitor change as we turn it. Yeah, I've got the code going up right now. I'm typing it as we speak, so you can just follow along with it. And then I'll also put the code up in the chat box too. You can't see it. It's over here on the right-hand side. Maybe you got a window in the way. Okay, I guess for reference, is everybody done working with the circuit? Because if that's the case, then I'll full screen the code. Okay. Well, let me go ahead and beep. There, is that better? It doesn't go any higher. It's at the top of my screen. I'm at the top of it. There is no scrolling to be done. Again, okay, cool. All right, so want to make sure I have this right where the potentiometer should be facing. Oh, I have it pointing to the left. So the terminals are sticking out to the right. Let me go ahead and zoom in on it. Like thus. So that. This. For sure. Okay, so back to the code. Here we go. This is what we've got so far. We've got 3 variables, sensor pin, LED pin, and sensor value. Sensor pin and sensor value are both set to 0, whereas LED pin is set to 13. And again, this relates to the pins that are plugged in on the circuit, except for sensor value. We'll get to that in a moment. So sensor pin 0 because A0 on the Arduino, LED pin 13 because pin 13 on the Arduino. Then we're setting up our pin modes as well as the serial begin. So we set our sensor pin to be input, and we set our LED pin to be output. And then we're setting it up so that the serial monitor will begin reading values from the Arduino that we will write out, for funsies. Now, here's where the magic happens in a void loop. We're going to say sensor value equals analog read sensor pin. With me so far? Basically, we are just taking in the value from A0. an analog value from A0. And then we're going to say serial.println sensor value. And that's just printing out the sensor value to the serial monitor so we can see it update in real time. Now here's where things get interesting. Digital write, LED pin high. And we're going to put in a delay in a moment here. Digital write, LED pin low, and another delay. Now here's where things get a little bit interesting. We're going to fill these in with, instead of a hard-coded value, the sensor value. So this will change as we turn the potentiometer. So based on this, what do you think is going to happen? Just take a stab at it. Fair enough. Honesty is good. So, as we turn the knob on the potentiometer, that is going to increase or decrease the amount of voltage that is coming out on that middle terminal, right? So that voltage is either going to be a larger or a smaller number. This analog read is reading the value from that middle terminal. Now, the interesting thing about an Arduino is it can take in a maximum of 5 volts, but it's not going to read it as 5 or 4.2 or whatever. It's going to read it as a value from, I think, 0 to 2500 or 1000 or something. I don't exactly remember off the top of my head. It's going to place that value into sensor value. So that number anywhere from 0 to 1200 or 2500 or whatever. It's going to print it out to the serial monitor, it's going to turn on the LED, and then it's going to wait that amount of time in milliseconds. So if the potentiometer is at full resistance, we're going to get a number pretty close to 0. So sensor value is going to be pretty small. So the delay is going to be pretty small. So the LED will just blink on for a moment and then blink off really fast, and it'll just start strobing like crazy. We turn it all the way up, so it's no longer resisting very well. You're going to be getting a large value into sensor value. Sensor value will then be fed into delay, so the delay will be longer, so the LED will be blinking much more slowly. So the LED will be blinking faster if the resistance is higher on the potentiometer. And it'll be blinking slower if the resistance is lower on the potentiometer. So let's go ahead and test this out. I'm going to copy paste this code into the chat box as well so you guys can review it against your code in case you run into errors or whatever. And I'm going to put it into our code editor. Boop. Upload and run. And if I pull in the serial monitor, as you can see, we're getting values very, very slowly, and this is blinking very, very slowly. And the maximum is 1023. There are 1024 values that can be read, including 0. Now, as I turn the potentiometer, you might also notice that we're getting updates faster, and the LED is blinking faster. Let's turn it up a little bit more. LED is blinking faster. Yours isn't working. Is the code not working, or is the thing not blinking? Turn it all the way up. Now we're getting zeros, and the LED is pretty much just staying close to on. Now we're getting a bunch of blinks. The code is not working. Okay, is it giving you an error message? what is that error message? And what line has it highlighted? Just copy paste that line in the error message. Ah, well, first of all, there is, check out the difference between those two and those two. And I'm not sure what's going on with that. How about copy pasting the line just before it? Interesting. What is the error message you're getting for that LED pin one? Okay. Oh, I see, I see. All right. So check out the responses I sent to you. One of them is the spelling of analog. The other one you want to make sure is setup is a single word. And then the third one, well, the thing I noticed is you've got sensor equals 0, and then you refer to sensor pin. You want to make sure that instead of sensor equals 0, you've got sensor pin equals 0. Like so. That looks like that will probably that'll probably handle all the error messages that I see there. Yeah, for sure. All right, so with that, we created a nice blinky light. Now, granted, because it's a simulation, it's not going to blink as quickly as it would in real life. This would be pretty intense in real life, I'll tell you. May not be a great thing if you have epilepsy to turn it down to very low values, but at the very least, we at least got that. Let's see here. Are you running into an issue, Cohen? Or is yours doing all right? What's the error message? Oh, I see. That first delay, you have yeah, you want to make sure that's a sensor value. Try that again once you fix that. See if that doesn't fix the issue. Also, you've declared sensor value as this initially when you want it to be that. Still isn't working. Is it still the code? Why don't you copy paste your whole code into the chat box so we can take a look at it? Or sorry, there were two different people responded to that. Is it still your code, Hannah? Okay, copy paste your code and put it into the chat box. In the meantime, I'm going to do the poll questions for everybody so that we can get that out of the way, and then I can help troubleshoot with everybody's circuits and stuff like that, and then we can do the thing with the question and answer, and you guys can head out for the weekend, and then we can meet up again next Wednesday. Notice how I said next Wednesday. We don't actually have class next Monday because of Halloween. So, that should be pretty fun. You guys enjoy that, and, we'll do that.